All right, good morning and afternoon, everyone. Thank you for joining in today. My name is Nate Spurley, and I'm a sales engineer at RISA. For our limited time today, I'll be briefly discussing some of the features available in ADAPTBuilder for multi-story concrete building design. Though Builder can do post-tension concrete, our focus will be on traditionally reinforced concrete. I'll start out with a few slides giving a general overview of the capabilities and uses of ADAPTBuilder. Then we'll move into the program to show some of the features in greater detail. First, a few housekeeping items. Please be aware that you can connect to the audio using your computer or even by calling in. Also, please use the Q&A chat box to ask any questions you have. We have other engineers standing by to answer your questions. So what exactly is ADAPTBuilder? ADAPTBuilder is a three-dimensional finite element solution for building design in concrete, post-tension concrete, or a combination of the two. ADAPTBuilder allows you to model and analyze a complete 3D concrete building from foundation to roof, all within the same model. Specifically, you're able to analyze and design waffle slabs, beam and slab systems, podium slabs, as well as transfer slabs. ADAPTBuilder also gives you the ability to do full structural analysis and design, including lateral loading, load takedown, column design, and wall design. This allows you to get a better idea of the as-built behavior and design requirements of your structure. Having multi-level functionality allows you to bring all loads and actions down to the base of your model to design the shallow foundations systems. These include mat foundations, pile-supported foundations, specifically pile caps, spread footings, and even grade beams. ADAPTBuilder integrates with other platforms, making it easy to incorporate your existing workflows. You can import geometry from AutoCAD and Revit to construct your model, and then even export drawings from Builder. From eTabs and Tekla, you're able to import geometry as well as loading and reactions to design in Builder. You then proceed with drawing export from Builder for Rebar and PT. Here's a flowchart on how you could use Revit in combination with ADAPTBuilder. We're very proud of this method. It's almost a full round trip workflow. You would start with a Revit model, export the geometry to Builder, perform the design to obtain the PT and rebar layout, import the tendons and rebar back into Revit, and then create your plan sheets. Let's go ahead and get into Revit here. I can show you how easily you can create an ADAPTBuilder model. If we go over to the Analyze tab, I've installed our Builder Revit link. This will create a data file that can be read by ADAPTBuilder called an IMP file. Let's click it. If you have custom column dimension parameters, you can specify those here. We'll keep the defaults. Click OK. Here on the Levels tab, this gives you some flexibility on how the IMP file is written. However, most of these settings are going to be read-only. When we get to importing this IMP file into Builder, we'll have a little bit more flexibility. The None option will write all levels to the IMP file, even if a level is only a few inches tall. This can be a little bit detrimental or cumbersome if we have a 2-inch tall column, as the stiffness is going to be much larger for that column. So we won't use that option today. The structural level, or the structural option, imports only levels set as structural within Revit. And then the active, typically the recommended option, imports only levels that structural components are assigned to. Non-structural components that are attached to non-structural levels will not be imported. So we'll go ahead and use this option. On the Components tab, this provides a count of the items that will be written to the IMP file. For example, you can see it's picking up that we have a total of 29 beams within this model, 97 columns, 10 slabs, 31 walls, etc. Going over to the Load Cases tab, we don't have any in this model, so this is blank. On the Load Combinations tab, we'll actually deselect these and do the load combination creation in Builder. So I just select them and move them over here. They won't be written to the IMP file. Let's click Export Data. We'll give this file name. Let's call it webinar. Click save. And in no time at all, we have now created an IMP file ready for import in Builder, and we can set Revit aside. So let's go ahead and open Builder. Since this is a multi-level model, we'll want to make sure that we're using Floor Pro and Edge. We also are assuming this is a traditionally reinforced concrete design building, so we'll turn off the post-tensioning features. I like this a lot because it allows us to clean up the display by hiding all of the tools associated with PT. We'll use our US system units here and click OK. Upon opening Builder, we're presented with a ribbon-based UI, which is laid out in a logical fashion from left to right on how you would progress through a design in the program. For example, in most cases, you're going to need to model something before you start adding loading, and so on and so forth. In the middle of the screen, we have our model space, where the geometry and some results from our model are displayed. At the bottom, we have our quick access toolbar, which has features that are commonly used, such as snap tools, views, and component visibility. One thing I love about Builder is you're actually able to create your own custom hotkeys. For example, I have my snap tools hotkeyed to Alt-1, Alt-2, and so on and so forth. This helps speed up your modeling process without you having to learn hard-coded shortcuts. You can customize them to your needs and in a way that you'll remember. So let's get to importing our IMP file. If we go over to File, Import, IMP, we can navigate to the IMP I created, click Open. And here's where we have a little bit more flexibility on what is brought into our ADAPT model. On the Components tab, you can import the entire model, or you can import just a specific level. Notice that in the IMP file, all of the levels that were in our Revit are available. You could also just specify a specific level and update it. Say you already have a model, the column layout changed. We could say, okay, let's import level 3 and just import the new column layout. And click OK, and it would import it. We're going to create the whole new model. On the Load and Load Cases tab, this is empty as it was before since we didn't have any in our Revit model. The Load Combinations tab is also empty because we removed the load combinations. Let's click OK. And in seconds, our model has been created. We can see this entire model in an isometric view or in a rendered view by going down to our Quick Access toolbar. Here's an isometric view. Let's go ahead and open our rendered view. Spin the model around, take a look. As you can see, all of the openings were included, even some beams or columns, and there's even a slight step on this balcony out here. So the model creation using Revit is pretty straightforward and easy. We could proceed with going through the design and then exporting our rebar and tendons, if this was a PT project, back into Revit for drawing production. This ultimately will save you a bunch of time by removing a lot of your redlining process, as well as back and forth that you'd probably have with your drafting team trying to get your drawing set up. Now, when I worked in ADAPT's consulting branch using Builder on a daily basis, my preferred method was using our AutoCAD import because our projects were typically very fast-paced and revisions were constantly happening. So let me show you how creating a model from AutoCAD is pretty quick and simple. So let's create a new model real quick. We won't save those changes. If we go into File, Import, we can import a DWG. And I have one set aside here, typical levels. Click Open. And here we have a couple options to proceed with. We want to calibrate the drawing so that the scale in our AutoCAD matches that within Builder. We want to make sure that dimensions line up and make sense. We can also translate the drawing, say if we had any geometry already within the model and we wanted to line it up. Say if a level had particular changes and we received an updated drawing, we could overlay it and then trace over that CAD drawing. We can also insert it at a specific level within Builder, and then we can assign it a CAD group. I highly recommend that you do this because it helps you ultimately keep track of the different CAD files that you would import into your model. And then you also have the ability to turn them on and off. So let's go ahead and call this typical level CAD. Click OK. So right now we're in an isometric view. Let's go back to our top view. You can see at the top here, the program is prompting us to calibrate the drawing. So if I zoom in here, I'd like to pick a easy dimension. Let's use this 20 feet. I'm going to turn on some of my snap tools down here. Click there and there, and we will enter this as 20 feet. Click OK. Now it doesn't look like much has happened, but we can verify that the drawing is calibrated correctly by using this measuring tool here at the top. So let's maybe try this 10-foot dimension. You can see 10 feet. Looks like everything is good. One great thing that I love about the CAD drawing import is it's not just the line work. It actually imports the layers too. If I click on this grid line, you can see this tutorial level 1 grid line layer is here. These grid lines are going to get in my way a little bit, so I can actually turn these off by going into our layer settings, scrolling down and finding that layer. Here's the grid lines. Click the little light bulb. And there, we've cleaned up some of the grid lines now. Now, these items that we imported from CAD are closed polygon lines. And this is going to be useful because in our modeling tab, we have a transform items for different components. So here I've selected a slab region. And if I just click transform slab, very quickly, I have now created that slab. Do the same thing. Now I can go through and individually select all these columns, but that might take a little bit of time. So I go into my home tab, I actually select by a layer. And since these columns were on their own layer, I can select the column layer. All the columns are now selected. Go back to my modeling tab and transform these into columns. Quick and easy. Let's do the same thing with the walls actually. So we go into home, select by layer type, wall, go back to model, transform into walls, just like that. There's a couple openings. I can simply control click those. There's not too many. So let's transform those into openings. And then we have a beam down here. So do the same thing real quick. And there we go. Now, a feature that makes Builder very powerful when it comes to complex geometry is how it handles nesting of slabs. You can simply add steps, thickenings, and depressions by adding slab regions. So let's go ahead and add a slab region here. Let's say there's a depression in this area. I'm just going to freehand it, so it's not going to be the prettiest thing in the world. We'll go with that. Now, the CAD is no longer needed since we've constructed the model. So if I go over to the Visibility tab and click our group library, you can see here's the typical level CAD group that we had assigned earlier. If I turn this off, all the CAD will go away. It's still within our model, but since we don't need it, we can turn it off. Now, if I double click this slab edge, we can see we have an 8-inch slab with no offset. Let's say this nested slab that I just created is a depression that's a little bit thinner. So maybe we make this 6 inches and we'll keep the slab soffit uniform. So positive is down. We'll click the green check mark to accept that. Now, how can I verify what I just did? In the Visibility tab, we have a section cut tool, which is very useful for actually understanding exactly what's going on within a 3D space. Sometimes it's hard in other programs to know what is happening, but if I draw a cut through there and zoom in, you can see I have a little bit of a step there, my 2-inch step, 6-inch slab there, 8-inch slab there. Very useful tool to see what's going on with your geometry. You could also go into your rendered view or side views and look that way as well. Let's go ahead and actually add an offset to this balcony here. Maybe we'll just have it go down 1 and we'll change the slab thickness to 7 inches. And accept that. Now I see a potential problem. We have a column that's overlapping 2 different slab thicknesses and at different offsets. Same with this wall here. If we go into a side view, we can see a little bit better what's happening. You can actually see that this column here and this wall are sticking out above the slab. That's not a problem because we can go over to our model tab and use this wonderful feature called Connect Supports. If we simply click this, it'll bring all of the supports down to the bottom of the slab. Just like that, that fixed that problem. Let's go back into, well, this view is fine for now. As you can see, we only have a single level at this point. And this brings up the next unique feature about Builder. You're able to analyze the structure as a whole or in a multi-level setting or just a single level. Having single level mode is useful because it allows you to fine-tune design of a particular floor or even check that the design is still adequate if changes were made. This makes it so you don't have to wait for the analysis of the entire structure. So the way you can switch between these modes is by using these 2 features here. Right now we're in single level mode. Let's actually take this model and turn it into a multi-level structure. So we go into our level assignment, we can add a couple more levels. Right now we have a top plane, current plane, and bottom plane. So if we add a couple levels here, maybe we'll add 2. We can even rename it. Let's call this one roof. We can change the height. We'll just leave it as is for now. And we'll close this. Now let's switch to multi-level mode. You can see all of our different levels are listed here. So I can turn this into a multi-level structure by selecting my typical floor, going over to modify, and copying this vertically. Let's copy it up 3 times. Click OK. And just like that, we have a multi-level structure. Now we're probably going to have another component connection issue here. Again, not a problem. We'll just go over to our handy tool that I showed earlier, Connect Supports. Just like that, it dropped all of those walls down to the slabs, and they're now connected properly. Now that we have a model, let's add some loading. I can either select by type in the Home tab and go and select my slabs to add loading to them. Or in this case, since we have very typical geometry, I can simply window over my slabs. Now it looks like I'm only selecting one slab, but keep in mind I'm in multi-level mode, so I'm actually selecting all the slabs in my model. You can see that here. So now if I go to our loading tab, I can map a patch load to my selected slab regions. Let's use 10 PSF dead load, create. Let's also add some live load here. We'll go with 40 PSF. Click create. Now the scale is a little off with this, so we can go into our select view items, go over to our loads, and we can decrease the symbol size here, which will drop down the scale. And that's a lot more reasonable, and you can see what's going on. The live load is scaled properly to our dead load here. You can see they're applied to all the slab regions. Let's go ahead and add some lateral loading as well. It's pretty quick and simple with our wind load wizard here. So if we click here, this brings up our wind load wizard window. You see we have a couple of different parameters that we can put in. Here's the direction. We can include an orthogonal as well. You can specify the exposure heights and then your typical wind parameters. Let's maybe say we have 100. We can set up user defined and even include torsional moments and whatnot. So let's apply these forces. In a top-down view, you can actually see we have our windward forces in the X direction and even our leeward forces in the X direction. Now, as you saw, our view is getting a little crowded, so we have our default display button here, and this will just revert the model to a display of your choosing that you saved. I like to just have the geometry shown up so I can clear any results or loading, and just keep going back to the geometry as I need to very quickly. So if I click this, you can see all the loads go away. Let's go ahead and add some seismic load as well. Here we have to do it a little bit differently. Let's call this EQX. We can specify our spectral accelerations, our modification factors. We can specify an eccentricity and a couple of other things. I'm just going to keep the defaults. We'll click apply to load case. You can see we actually added an EQX up here, and we can update that if we wanted to. Now, we're going to go ahead and add some load combinations real quick to include those lateral loads that we just added. It's fairly straightforward. Simply click here, determine which combination you want to do. Let's add a strength combination. Maybe we'll call this one Wind X. And I'm just going to use some basic ASCE 7 load combination. You'd probably want to do the appropriate load combinations. So go 0.9 for self-weight and dead load. And then we're going to add a factor of 1 for our wind. I can actually clone this since it's going to be similar for our seismic. Let's call this Seismic X. If I can spell Seismic X, and we'll change this factor here. Move it over to our EQX. You can see that there. We'll click OK. Now, we could have added more load cases using this load cases tool here. Say we wanted to add some snow load, we could add it here and then specified that as a snow load when we loaded our slabs. We also have building loads due to the seismic and wind load wizard. These are broken down differently based on how we are analyzing our model. In single level mode, we're going to be using these load cases. In multi-level mode, we're going to be using our building loads and our general loads. So let's click OK. Now, one thing I forgot to mention here is you'd add your load combinations here. And what you can do is you can actually save a template for your typical loads. The builder template will save your load combinations, your material properties, and your model criteria, which we haven't really talked about criteria. We've just been assuming the default. So let's go ahead and save this model real quick, and then we'll move into the criteria of this model. So over here on the criteria tab, we have a few options to specify our material properties. For concrete, you can change the unit weights as well as the strengths and the modulus of elasticity. And if you have a different concrete material, say for your columns and walls compared to your slabs, you can simply add another concrete material. We can change it, say it's 5,000 PSI. It'll update the modulus of elasticity for us. Let's actually differentiate this as 5,000 PSI concrete. We'll select OK. I could go in here and I could select by type, or I could individually select columns, and I could assign the material as I needed. Right now we're set to concrete 1. We'll keep that for now. In the rebar, we're able to specify our strength and modulus elasticity as well. And then we're even able to add steel fiber reinforcement. If you click here, this is simply going to open up our concrete property, material property window. But if you click here, add drawmix, you're able to specify the design type, whether it be a pile supported slab or an elevated slab. You can specify the fiber type, your dosage, and some applicable factors and specification for that. Notice it created its own concrete material here. We'll click OK. Moving down the tab a little bit more, we can actually adjust our analysis and design options here. So if we open this up, we have several options that we can play with. For example, we can specify the support condition that we want the program to assume for single level analysis versus multi-level analysis. So when we're analyzing in single level mode, we're assuming a roller support and rotationally fixed at the base. Whereas if we switch to multi-level mode, we can see we're fixed in position and rotationally fixed at the base. We're also able to change our design code here. Notice that some of these options are grayed out. That's simply because we selected US units. If we had selected SI, these would become active and we'd be able to choose a different design code. We're also able to adjust our shear and punching shear options. For example, if we wanted to use stirrups instead of stud rails, we can specify the sizes of our stirrups and stud rails, however we see fit. And then we have some code options here. For example, we can limit the rail spacing to 2 times the effective depth. We'll go ahead and turn that one on. We're also able to specify our rebar lengths. This is a length to span ratio here for top and bottom steel. We're also able to use rebar roundup. So if the program determines, hey, you need just under 5 number 5s, it'll round it up for you. You can specify your spacing as well. Here we have our minimum covers to use from our extreme fibers. And then we're even able to specify our preferred reinforcement size and materials. Now notice over here we have different design criteria for 2-way, 1-way, and beam. Some of these options over here are actually unique to these. So if I go into beam criteria, for example, and I change this to, say we want a number 10 bar on the bottom, this is unique to the beam criteria. So if I switch to 2-way, it changes back to 8. So we can set these up as we see fit. So now that our criteria is all set up, we can go ahead and move into doing the fun part and doing the design and analysis of our structure. So let's go ahead and first mesh the entire building. So if I go over to analysis, I can click the mesh generation tool. So our automatic mesh generator is very powerful. It determines the mesh almost just for you very easily, and can it's very painless to say the least. So what you can do is you can specify, hey, do we want to consider wall openings or not? We don't have any wall openings in here, so we'll just leave this as disregarded. The program also comes up with a suggested cell size. In this case, it's a 3 foot by 3 foot. It's going to attempt to create a quadrilateral elements using this. Now, we can also specify if we want a sparse or uniform mesh as well. If we increase the cell size here, now our analysis time is going to go down, but we may be neglecting some results here. And conversely, if we lower this, we're probably going to be able to mesh to much more complex geometry, but our analysis time is going to go up. I'm going to leave this default for now. It's usually a good starting point. And then we're even able to do some node consolidation with shifting nodes. I don't always personally model and snap components perfectly, so this is just a good way to kind of account for that. And then also, in a way, or so to speak, bridge the gap between what we're modeling and what the program is interpreting what we're modeling. So let's go ahead and save and mesh the slabs. Now the program is going through each slab individually in the whole model since I am in multi-level mode and meshing them. You can see that here. Let's go ahead and turn the mesh off just to clean everything up. And as I mentioned earlier, we can analyze the structure globally as a whole, or I can move into single level analysis. Let's go ahead and just do single level analysis for the time being. Maybe we'll go to our plane 4 here, which is the level just below the roof. So I've meshed. We go into analyze. I can execute the analysis. This brings up our analysis options window. I can click which load combinations I want to use. Since I'm in single level mode, the building loads I'm not going to worry about. So let's do a service total load combination as well as a dead and live load combination. And click OK. The program is going through the analysis for this single floor right now, more or less disregarding the other levels in the model. We'll click Save the solution. And now our results viewer pops up over here on the right because we have a solution. we can go into our loads tab and it'll show, hey, which load combination are we using? In this case, we have service total selected. I can go into analysis, select the slab, and I can actually see the deformation, the Z translation. We have our legend over here showing kind of the extreme values. Now, the text is a little small, not a problem. I can go over to our home settings, text settings. Let's increase this. Let's double it. And now you can kind of see a little bit better what's going on with the values. We can even see a warped form of this. So if we go into our rendered view, maybe turn this to the side, we can select a warp view here. Looks like everything's deflecting properly, but we can even make the structure dance a little bit, make sure that we actually have the expected connectivity between components. Doesn't look like we have the slab punching through any column or any wall that's not supporting it. So it looks good. So now might be a good time for us to actually make sure, hey, are we going to have any punching shear issues? So if we go over to our floor design, we can execute our punching shear check. This was taking into account any strength combination that I had. I only analyzed for the one, so that's what we're checking. If I go over into our analysis tab, well, let's first make sure we're actually on the strength load combination so we get results. So simply switching it there. Now we can see punching shear dropdown has been added, and we can check our punching shear. The colors are a little grayed out simply because we're seeing the columns on top. Let me hide these real quick. Just window select them, go to visibility, hide selection. Now we can go back to a top-down view. There, now you can see them a little bit better. So you can see these columns are all okay. These ones the program are flagging, hey, you're going to need to reinforce these. We can actually check our stress ratios. You can see obviously the ones that need reinforcement are over our 1.0. We can even see the condition, how the program is treating these, whether it's a corner column, an end edge column, or an interior column. And we can even see the reinforcement that the program is recommending. So if we zoom in here a little bit, you can see we're going to need 11 rails, 3 stud rails on one side, 4 on the other, 7 studs at 3 inches, and the total length is 21 inches. We could even see this in a report view. So if we go over to reports, go to punching shear, we can see our stress check results. This will open a Word document for us to look. Let me see if I can zoom in here a little bit for you guys. Oh, that was a little too much. There we go. So you can see our stress ratios are listed here, the column, how the condition of it, our factored shears, our factored moments, stresses due to shear, stresses due to moments, total stresses, etc. Very quick report, easy to see and read. We can even go into our punching shear reinforcement, which is going to generate a stud rail schedule for us. You can see here, here's the column name and the IDs, as well as the number of rails and the diameters, rail lengths, stud spacing, and number of studs as well. So we'll go ahead and stick with this. This will be adequate for now. So let's go and actually design this floor. But first, we're going to need to add support lines. The support lines are how you specify design strips and section cuts for the program to actually do the design. So when I was in our consulting group, the way to add support lines was simply using the create X support line and create Y support line. Now, what you do is you would go through here and you would have to snap to the slab edge, click snapping to the center of the column, click snapping to the center of this column, and snapping to the slab edge. So you get kind of quick using it on a daily basis. But one thing that was added and is a fantastic feature in my opinion is this dynamic editor. And it saves so much time creating support lines. All you need to do is simply draw a line that intersects through your columns and click. Now if I press C on my keyboard, it'll create a support line. Let me pause this real quick. If I click here, you can see it snapped. Points to the slab edge, to the column, and to the slab edge as well. So let's go ahead and add a few more of these. We'll go here and about there. One more here. One more here. Now, when we generate sections, the program is going to look for one adjacent support lines. So the support line, I need to close this. This support line here is going to look for this support line here, and then it's going to split the difference and create sections. The other item it's looking for is a slab edge. Now, since I'm not going to go through all of the support lines in this model, but since I'm stopping here, we need to tell the program, hey, we need to stop these sections so that they don't cut all the way out here. We can do that by adding a splitter. Splitter is just a boundary for our support lines. So if we draw one right here real quick, that should be good. Now, if I click Generate Sections, you can see the program has generated sections based on adjacent support lines, the splitter, and even the slab edge. And these are the section cuts that the program is going to be taking to design the slab. So if we click Design Sections, the program is using the analysis that we determined using single level mode. And now we have some results. We can go over to our Analysis tab. Let's collapse some of this, clear the view. Here's our design section results. Drop down here, we can check deformation. This is going to give our span to deflection ratios. You can turn off the section cuts if we want everything in green as passing. And you can even specify in the display, hey, what is my maximum span to deflection ratio? So that's fully customizable there. We can even go into our actions. We can check our moments, for example, shears, even torsion. And if we go into this investigation tab, we're going to see moment capacity as well as moment capacity with demand. Now the program has calculated amount of rebar, but we're not seeing that. So what we can do is I'm going to clear the results real quick. Let's go back to our default display actually. And I can calculate a rebar plan. I can envelope the results and click OK. And you can see there's rebar calculated based on the analysis that we have done. Now, there's only rebar in the X direction because I only added X direction support lines, no Y direction, and it's only in this area, again, because there's only support lines in that area. We can actually take this and export it to AutoCAD. We can change some export settings here, such as our font sizes, symbol sizes, and whatnot. I'll keep the defaults. Now if I go to File, Export, DWG, I can specify, hey, what version of AutoCAD do I want to use, as well as if we had tendons, we can specify if it's going to be a spline or other objects. For now, we'll just click OK. Let's save this. Maybe we'll call it Rebar. Click Save. Now, if I go over to the drawing I just created and open it, I can zoom extents, and you can see just like that, we have rebar in our model. Now, obviously, there's going to be a little cleanup that needs to happen. We have some text overlapping. You could do that. You could also apply your style sheets, but very straightforward and easy to get a rebar drawing created very quickly. Let's go back to our model and maybe move into the design of our vertical elements. Oops, that's not what I wanted. We'll reset the display. So if we're going to move into column and wall design, we're going to most likely want a full building solution. Now, we could have gone through and designed each individual level and produced our results there, but we'll just go to our full building for now and do our column design. So let's say we want to design this single column stack right here. I'm going to select it and hide the rest of the components in the model. So simply window it, go to visibility, and I can show this selection. Let's go to an isometric view. Now, with this selected, we'll go over to our column design and we can define a section type. You can see, since I imported this from CAD, it assigned a lot of section types for my columns already. In fact, this column stack is assigned as a 30 by 18, but let's say we want this one to be unique. So I'll go ahead and add a new one. And since they're 30 by 18, I'll call them 30 by 18. Let's call them 30 by 18B. If I select this, I can assign 4 selected components to this one design group. Click OK. Now, I wasn't quite done there yet, so let's open this back up. And we can actually change, and it looks like the program is going to change the dimensions. So let's change these here to 30 by 18. So that's what the size of these columns were. You can see up here we were able to actually change the concrete material. Earlier we added that 5,000 PSI and even the Dromix steel fiber concrete material. We changed the dimensions. You can see our row value. Let's go ahead and add a little bit more reinforcement to this column. Maybe we'll do, let's increase them to maybe number 8. And let's say we have 4 bars on that face. Oops, click outside. We'd also be able to specify our tie size, tie spacing, and those types of items as well. So that looks good for this column section. Let's click OK. Now, if we go into our design settings, this is where we're going to specify we're checking this for design. Now, we have an FEM solution, so let's use the FEM solution as our force source. You can see this now gets selected. It looks like I forgot to analyze in multi-level mode, so let me do that real quick, actually. So I'm going to reset the display. And going to analyze here in multi-level mode. So we'll turn multi-level mode on, analyze, execute analysis. Let's select our lateral combinations. My apologies. So now when I click OK, the analysis is now determining a solution for every single level in our model and for the load combinations we selected, including the dead load, the live load, the wind load that we added in the X direction, as well as the seismic load that we added in the X direction. So this should only take a moment. And as you can see, it takes a little bit more time going through the multi-level solution, whereas if you're trying to refine the design of a single level, that single level option can save you a bunch of time if you're doing some iterative process. So let's go back to where we were with these columns. I'll hide everything else. Visibility, show selection. Let's go back into our column design, design settings, switch this back to FEM. Now you can see we have our seismic and other load combinations here. You'd be able to adjust the code as well as any design constraints. Say you want to freeze the dimensions of your column, or if you want the program to optimize them, you can adjust that here. I'm going to leave that as is. Let's click OK. Actually, I'm going to turn off the service load combination. I just want to analyze for strength. So we'll click OK there. Now we can go ahead and code check the columns. So we click here. You can see I have all the columns selected in the model. Now I have them hidden, but if I went through and selected these, the program will highlight the columns appropriately. Since I have these 4 columns here and I select them, you can see they get highlighted in red. So I'm just going to design that stack. We'll click OK. Now the program is going through each of these columns individually and checking them based on their unique loads, determining the full determined from the full building analysis and the section type that we defined up here. So this will only take a moment as well. And there we go. We have some code checks for our columns. If we go over to our analysis tab, we can open up the column. And then we can go into our drifts, for example. And we can see some drift values. Well, that is a little, the font there is a little small. So I believe if we go into, actually it's in our display settings. If we go down here, let's maybe up this to 12. Click the check to apply it. And now you can see it a little bit better. Let's go back to our analysis. So you can see drift combined, drift X, drift Y, and whatnot. Looks like something is a little funky there, but no big deal. Now we can also see the individual column design results. Let's turn this off. You can see our status here. They're showing that they're all okay. We can see our B&T utilization as well as our N and M utilization. As you can see and would expect, it increases as you go down the column stack. So we could go through, we could assign different section types to different groups of columns. We could design all the columns using this method. You're actually even able to say, we right click this, go into column design. We can view the design summary for this column. And you can see a report showing, hey, this column is acceptable. You can see the utilization. We have material properties, gross properties, loading that is being brought in as well. Our factor design loads, some of the N and M results, shear and torsion, tie spacing requirements, vertical steel area, vertical bar spacing. And then if we had any specific messages or issues, they would be listed down here. But since everything looks okay, we don't have anything displayed there. So we can close that. So we can say that our columns are designed. Maybe now we move into our wall design. So I'll reset the display using our default display button. Let's go over to wall design and we can show the walls only. Now, if we select, well, in order to design, we're going to have to assign peer labels for these wall stacks. So I'm going to just design this one for now. So if I go in here and define peer labels, we have a default P1 in here. I can select it and click assign, and that is going to assign it to those walls. If I wanted, I could add a couple more here. We'll just stick to this one wall stack for the time being. So click assign and OK. And I can verify that that was actually assigned by double clicking this wall. You can see here, peer P1. So indeed, it's there and it's good to go. Now, if we go into, first we're going to have to generate our wall sections. I only had the one selected, so it's only going to do that one. There we go. Now, the program added wall sections just for the stack because that's the only one that was defined as a peer. Earlier, I had that one selected, so it only generated sections for that one. Now, if we go into our wall design manager, here we can specify our rebar layout of this wall stack for our panel reinforcement as well as our zone reinforcement, both our vertical and horizontal bars. But let's first look at our design parameters. So in here we have a couple of options that we can pick from, whether we want to change our boundary method, for example, if we're checking our boundary elements, the maximum utilization, our section type, section thickness, our unsupported wall height. Let's change this. Our story height was 10 feet, so we'll do that. And then in here, we can select the load combinations that we actually want to design this wall stack for. Based on our multi-level building analysis that we did earlier, these are all of the load combinations that we have available to us. Once we actually design, we'll have a P&M diagram here as well. So let's go over, our load combinations are selected. We'll go into this design section here. Maybe we'll go to our bottom wall here. And you can actually change the views for this wall if you want like a CGS view, if you want the actual wall length, or if you want kind of a trimmed view. I like this trimmed view. You can kind of see the reinforcement a little bit better. But let's go ahead and adjust some of these parameters here. So maybe we have, let's reduce some of this rebar. It seems a little high. We'll do that. You can see the program is saying, hey, you can't have this combination of rebar. So we have to change this there. There we go. So that spacing looks good. We could change the number of curtains. Maybe we only want one curtain in this case. We can change the spacing of our bars. Now we can click code check. I think this is adequate for now. So click code check, and you can see the program is reporting that this is unacceptable. So if we view the design summary, it's going to open up something very similar to what we saw for the column design. You can see, our status is unacceptable, and right here we're saying, hey, our area of steel, we're having some issue where we're not meeting our AB min. So we could change that for our horizontal bars. Maybe we decrease the spacing, we add another panel, or maybe we increase the number of bars, and so on. So let's go back here, and maybe we'll drop this down to, say, 10. Maybe we'll drop this to 12. We can code check again. Still unacceptable. Let's see why. Oh, just barely on our horizontal bars. That's okay. So we can adjust that real quick and call it good. So let's change this to 8. Code check. Now it's acceptable. So if we wanted to apply this design to all of our walls, we can actually simply copy the reinforcement first. So click copy, and then I can go through here and select each one of these. Probably could just click that one, click paste. And there we've just assigned our rebar layout for all of these walls. Quick and easy. Let's see if I can get it to show. There you go. And we could actually go in here and click code check and code check all of our walls. And if we go in here, we can even see our P&M diagram. It doesn't want me having more than one. So you can see our P&M diagram generated here. We can even show our load cases. Now, obviously, this is well over designed, but that would be up to you to kind of refine those results there. So that more or less concludes with the design of our model. Now maybe we want to generate some reports that we can show to specify what we've done. Now we can go over to our reports tab here, and we have individual reports you can create, such as rebar, your loading, your structural components, or you can simply use our report compiler. And in here you can select and pick and choose whatever you want to apply. So maybe we are going to do a graphical, let's do a structural plan with the plan geometry. And maybe we do, let's see what we have in tabular here. We do some analysis data, design section data. We'll just do these basic ones so that we're not sitting here waiting 10 minutes for the report to be generated. So if I go in here, generate compiled report, you can pick either RTF or PDF. If you want to make some modifications after the report's generated, you can select RTF. I'm going to do the PDF report. We'll keep it as portrait. Click OK. You can see the program's going through and actually generating the different reports there on the screen. Here it opens up. You can see I just have the plan geometry, which I selected. The report cover, I believe, is text only. So if I would have selected the RTF, I would have had a report cover. But that's how you would generate the reports. We did discuss kind of the punching shear report as well a little bit earlier. You could add that in as well. So at that point, we've more or less designed an entire multi-level concrete structure within Builder. So I appreciate everyone's attention during this brief overview of ADAPTBuilder, the robust and easy to learn finite element solution for concrete building design. I hope that you all learned something today and had a chance to get your questions answered by our awesome team of engineers on the call. This webinar is PDH qualified, and you will be emailed your certificate within the next day or two. The recording will also be available on our website and YouTube channel. If you're wanting to learn more about ADAPTBuilder or more about the other ADAPT products, I invite you to check out our YouTube page or to email adaptsales@risa.com. If you are interested in the post-tensioned aspects of Builder, we will be more than happy to provide additional information or set up an online presentation for your firm. Thank you again for joining us, and we'll see you next time.